So today will be a review for dynamic routing protocols. So we'll start by some questions. Here we'll practice on some question. But in the exam you may have the questions in different form, in multiple choices or in complete answer or so on. So I will just give you some um, examples of type of questions, but the same information uh, can come with different form. Yeah. But first, what are the main functions of dynamic routing protocols? This is in the first part, why we studied dynamic routing protocols, or what are the main functions of a dynamic routing protocols. Here you can find the answer coming directly from the slides. So dynamic routing protocol are used to maintain or to implement connectivity on the internet or connectivity between different group of nodes. And the main functions of dynamic routing protocols are three main functions: dynamically share information between routers, to start to exchange information and start to building routing table. Second, automatically update routing tables when topology changes. So after sharing information and building routing tables, if there are any change in the network, we automatically update a routing table. The third part and the main function of dynamic routing protocols and the final objective of a dynamic routing protocols is to determine the best path to destination, to each destination. So these are the main three functions of dynamic routing protocols: dynamically share information between routers, automatically update the routing tables, and determine the best path to a destination. These are the main functions of dynamic routing protocols. In this chapter also we have different and many definitions and many comparisons between different techniques, different protocols, different terms. So one of these comparisons is compare between the static and dynamic routing protocols. So we have static routing protocols and dynamic routing protocols. This chapter focuses on dynamic routing protocols, but we should also know the difference or the comparisons between the static routing and dynamic routing. So for this is the comparison from your slides, static routing and dynamic routings. We have different matrix or different parameters we can compare with. First, from the routing point of view, in static routing, the user defined routes in the routing table. So we manually write or manually configure the routing tables, while in the dynamic routing protocols, routes are updated as per the changes in the network. So the routes or the routing tables will be updated automatically in dynamic routing protocols, while it's updated by the user itself or manually in static routing protocols. So from a routing algorithm point of view, no complex algorithm used to figure out the shortest path in static routing, because all things done manually, while in the dynamic routing, we implement or use complex algorithms to find the shortest path. From a security point of view, and it's a very important point, the static routing provides or gives higher security, while dynamic routing is less secure. And why we said that it's less secure? Because we exchange information. As I said, one of the main functions of dynamic routing is to exchange informations and updates between the different routers. Once we have exchanging information, or once we exchange some important knowledge or some important updates between the routers, we may be available to some security issues because we exchange information in public. So we may have some security issue, we may have some eavesdroppers or some hackers that can hear or that can edit or that can send wrong information during these updates. But due to sharing this information, dynamic routing is less secure, while static routing provide higher security because everything is manual. From an automation point of view, static routing is a manual process. The user identify or set all routing information by itself, by him, while dynamic routing is an automatic process. So we run automatic algorithm And these algorithms, these dynamic routing protocols, run automatically and automatically update the routing tables. From applicabilities, static routing is used in smaller network. Dynamic routing is implemented in large network because it's automatic and can update the routing table automatically, so it can be implemented in a large network. But the static routing, we did everything manually, so it's very hard to be implemented in large network. So it's usually static routing used in smaller network. Also, the static routing may not follow any standard or any protocol, while dynamic routing follow specific protocols like GRIP, like Border Gateway Protocol, like EIGRP, and so on. Static routing doesn't require any additional resources because everything is manual, so we don't have to have um, يعني we don't need to have CPU or memory to make some calculations and to calculate or determine the best path. Everything's manual, so we don't require any additional resources, while dynamic routing requires additional resources like memory and bandwidth and CPU to calculate the best path and construct, for example, in some cases, database, links to database to determine or define the best path, shortest path. All this process needs some memory and some bandwidth and some CPUs to make these calculations, to make this process. So dynamic routing require additional resources, while static routing doesn't require additional resource. But this is comparisons between static routing and dynamic routing, and every term or every parameter in this comparison is very important. Another question, what are the main advantages and disadvantages of a dynamic routing? And this also you can find this table from the slides. Dynamic routing has many advantages, like suitable in all topology where multiple routers are required because it's updates itself automatically, so it's suitable or can be implemented in any topology and large network. Generally, it's independent of network size, so it can be implemented in a small network and can be implemented in large network also. It's automatically updated topology to reroute traffic if possible. So if there is any change in the network, we can update routing tables, we can update the best path. So it's automatic process. This is the three main advantages of dynamic routing. On the other hand, there are some disadvantages, like it's complex to initially implement. So initially at the beginning, to collect information and start to generate a routing table at the beginning, it's a little bit complex to acquire or to receive or to collect all information from all nodes, from all routers, and building a routing table at the beginning. It's a little bit complex. Also, one of the disadvantages, it's less secure. So due to the broadcast and multicast routing updates, so out of sharing and broadcast the routing updates, it, additional information are exchanged between different routers and it makes dynamic routing less secure. The route depends on the current topology. So if the topology is changed, all routes have to be changed and we should recalculate the best path again if there is any change in the topology. And other disadvantage, it requires additional resources like CPU and memory and bandwidth to building a routing table and find the best path to all destinations. But these are the main advantage and disadvantage of dynamic routing protocol. Another comparison, if we need to compare between the interior gateway routing protocols and the exterior gateway protocols and mention one example for each of them. So question with two parts, but I take care to answer two parts. So the first part is what's interior gateway protocol and what's exterior gateway protocol. Interior gateway protocol used for routing inside an autonomous system. So it's used to route within the individual networks themselves or within the same, we use to make the routing within the same autonomous system or inside the same autonomous system, while the exterior routing protocol used for routing between the autonomous systems. So exterior routing protocols is used to route the information between the autonomous systems, while interior using inside the same autonomous system. And second part of the question, examples of an interior gateway routing protocol, RIP, EIGRB, IGRB, and open short bus first. And examples of exterior routing protocols, we have only one example, border gateway routing protocol. Another question, compare between distance vector and link state routing protocols. All this is categorization of our routing protocols. We have static routing and dynamic routing. Inside dynamic routing, we have interior gateway routing protocols, exterior gateway routing protocols. Inside the interior gateway routing protocols, we have distance vector and link state routing protocols. Here we need to compare between a distance vector and link state routing protocols. For a distance vector routing protocols, we have three main characteristics or three main features. Routes are advertised as a vectors of distance and direction, so we exchange updates or routes as a vector. This vector contains a distance to certain destination and direction of this route. This protocol assigns cost number to each link between each node in the network. Second, it has incomplete view of network topology. So when a node first starts, it only knows of its immediate neighbors and the direct cost involved in reaching them. So in distance vector, we construct or we generate incomplete view of network topology. And usually it uses or it includes periodic updates. So each node on a regular basis send to each neighbor node its own current assessment or its own information about the total cost to get to all destination it knows. So this updates or this collected information is sent periodically. So it can include periodic updates. These are the main three features of these characteristics of distance vector. For a link state, it has two main features. It has complete view of a network topology. So complete view of network topology is created through, if you remember, database, link state database. So router needs to learn about all routes and all routers on the network to find the best path. So each node or each router construct a map or link state database of the connectivity to the network in the form of graph showing which nodes are connected to which other nodes. So each node independently calculate the next best logic path from its every possible destination on the network. So every router or every node construct or generate complete view of network topology. And second, updates are not periodic. So we send the update here when we have changes. So updates are not periodic, unlike distance vector, which is usually uses periodic updates. If you remember, the only exception case for a distance vector, EIGRB, EIGRB used bounded updates or partial updates. This is only special case of protocols that doesn't use periodic updates. EIGRB. EIGRB is distance vector, but using partial or bounded updates, not periodic updates. But this is the only exception in distance vector. But usually, distance vector includes periodic updates. Another question, what are the used metrics for each of the following routing protocols? We studied different routing protocols. Each routing protocol use different metric to identify the best path or to build a routing table with shortest path. So you should know each protocol and which metric is used in this protocol. For example, REP protocol is using the hop count as a matrix. So it selects the path or shortest path as a function of the hop count. So the path with a minimum number of hops. EIGRB and IGRB using are using the bandwidth and delay as a default metrics and also load and reliability as optional. So IGRB and the EIGRB is using are using bandwidth and delay by default and load and reliability as option. Open shortest path first using cost as a metric, and this cost is a function of the bandwidth. What are the main advantage and disadvantage of a distance vector routing protocol? So now inside the distance vector routing protocols, we need to make another comparison. So for distance vector routing protocols, the main advantage are simple implementation and maintenance because we generate incomplete view or local view of the network. So we don't generate global view. So it's simple implementation and low resources requirement because we don't have to build a complete view of the network or complete database. It's low resource requirement and simple implementation. On the other hand, disadvantage is slow convergence because link state routing protocols is converge faster than a distance vector. The distance vector has slow convergence, limited scalability because of this slow convergence. It may limit the size of the network because in very large network it will take a very long time to reach to the convergence. So it limits scalability due to the slow convergence, and also it has the problem of routing loops. So routing loops can occur when inconsistent routing tables are not updated and also due to the slow convergence. And we study طبعا routing loops. Okay. Okay. Other questions. What is the definition of routing loops? So it's very important to know routing loops. So routing loops are conditions in which a packet is continuously transmitted within a series of routers without ever reaching to its destinations. So routing loop happen when the same packets are continuously transmitted between different routers without reaching to the destination. So the packet goes into a loop. So transmitted from router 1 to router 2 to router 3 and again to router 1, router 2, router 3 and so on. So it goes into a loop without getting out or without reaching to the destination. Uh, this is the definition of routing loops, conditions in which a packet is continuously transmitted within a series or group of routers without reaching to its destination. For solving these routing loop problems, we studied different methods that's implemented by distance vector routing protocols to eliminate or reduce the effect of routing loops or to solve the routing loop problems. It's very important to know the method used by distance vector. Remember, this method used by distance vector to eliminate effects or to reduce the effect of routing loops. We studied four main methods: setting a maximum, hold down timers, split horizon rule, and split horizons with Poisson reverse. So it's very important to know these four methods and the definition of each method or how each method is working. These four methods are used by distance vectorizing protocols to solve routing problems. On the other hand, what are the methods used by EIGRP protocols for eliminating or reducing the effect of routing loops? For EIGRP, we used diffusion update algorithm or dual algorithm to eliminate the routing loops. Take care of this. For EIGRP, we used the dual algorithm, while in general for distance vector routing protocols, we used the four methods: setting maximum, hold down timer, split horizons, and split horizons Poisson reverse. You have to differentiate between which method is used by EIGRP and which method is used by default distance vector routing protocols. And also, you should know how each method is working. Okay. What are the main advantage and disadvantage of automatic summarization? So you should know the automatic summarization definition, what's automatic summarizations, and what are the advantages of automatic summarization. So directly from your slides, automatic summarization advantage, we have two main advantages. The size of routing updates is reduced. So by using automatic summarization, we reduce the size of routing updates, and also طبعا the size of routing table. By reducing the size of routing updates, we reduce the size of a routing table. How? Because single routes are used to represent multiple routes. Because the main idea of automatic summarization is to summarize group of links or group of routers into one path or one network. We group these routes into one route. So single route can be used to represent multiple routes, which result in faster lookup in the routing tables. So by this summarization, we reduce the routing table size and we make searching inside the routing table faster. As the advantage, size of the routing update is reduced, size of the routing table is reduced, and single route is used to represent multiple routes, which result in faster searching inside the routing table. But on the contrary, on the other hand, disadvantage of automatic summarization, it doesn't support discontiguous networks. So if I have discontiguous network, automatic summarization will not work well. Uh, this is the main disadvantage of automatic summarization. What are the main steps of a link state routing? So our last part was link state routing protocol. So the main steps of link state routing protocol: first, sending hello packets to neighbor's node, and the main purpose of hello packets is to discover neighbors nodes and to make sure that all neighbor nodes are still alive. So first, sending hello packet, building a link state packet, which includes main link state updates, then flooding this link state packet to all nodes in the network. We mean by flooding, forward these link state packets to all nodes inside the network. So once you receive this link state packet, you will forward it to other nodes also. So we flood the link state packet to all nodes. Fourth, constructing link state database. After receiving all this information, we construct link state database. And from this link state database, we generate shortest path first tree. And once shortest path first algorithm determine short path routes to all destinations, these routes are placed in the routing table or generating the routing table. These are the main steps of link state routing protocols. Please, if you have any question or anything unclear in these questions, stop me and ask. Okay. What's true regarding the EIGRP routing updates message? Okay. If you have multiple choice, what's true about this or what's not true? So what's true about EIGRP routing update message? In the EIGRP send reliable update message using which protocol? Reliable Transport Protocol. So RTP protocol. So remember EIGRP is using the RTP protocol or Reliable Transport Protocol to send different messages of the EIGRP. And for EIGRP routing updates packets, it uses a reliable protocol because, as we said, the RTP protocol supports reliable and unreliable communication. So to send the update message, we use or EIGRP uses a reliable protocol. So the EIGRP sends reliable update message using the RTP protocol. What is the EIGRP TLV message format? This is from your slide. A TLV message can be IP internal if used to route within the same autonomous system, or can be IP external if we will forward this packet to external node. And this is the main format of TLV message. It contains next hop, delay, bandwidth, load, reliability, because all this matrix that's used to calculate the best path. الديستنيشن ادرس، المترك فيلد. طبعا المترك فيلدز which include delay, bandwidth, load, reliability, subnet mask, destination field. This is for internal, and for external it's used when external routes are imported, and it used some information for external nodes like originated routers, external protocol metric, and so on. But the main parameters that you need to know in a TLV message format contain a metric field, which is delay, bandwidth, load, reliability, subnet mask, and destination field. These are the main component that's included in TLV message format. Coming to the definitions, this chapter contains many definitions, so you have to study these definitions well and know every definition very well. These are some examples of these definitions, but you also have many other definitions in this chapter you have to focus on. This is just a group of definitions that's important, but there are another definitions in this chapter. One of the definitions is successor. What is the definition of successor? Successor is the best least cost route to a destination found in the routing table. So the best least cost route, we name it successor. Feasible distance is the lowest calculated matrix along a path to a destination. So the lowest calculated metric in any path, we name it the feasible distance, or the lowest cost or lowest calculated metric along this path. The feasible successor is the loop-free backup route to the same destination as successor route. Feasible successor, loop-free backup route. But the best route is the successor. But the other loop-free backup route to the same destination, we name it feasible successor. So it can be, if the main successor is failed or become downs, we can use a feasible successor as a new successor. But a successor is the best least cost route, and a loop-free backup route, we name it feasible successor. And a reported distance is the metric that a router reports or sends to a neighbor node or a neighbor router about its own cost to that network. So I report the distance, and it means I send the metric to the neighbor router. And the feasibility condition met when a neighbor's reported distance is less than the local router feasible distance to the same destination. So if the reported distance is less than my calculated or my local router feasible distance to the same destination, it means that the feasibility condition is met. I can use this new route as the best route because the reported distance is less than the local calculated feasible distance. These are some examples of the definitions in this chapter, and you have also other definitions like مثلا load balancing, convergence, and so on. So it's very important to know all definitions of this chapter. Another question, identify the main open shortest path first packet types and mention the function of each of them. So the open shortest path first protocol has many packet types, has five main packet types. So you should know these packet types and the function or the description of each packet types. And this is summarized in a table in your slides. The open shortest path first has five main packets: hello packet, database description packet, link state request, link state updates, and link state acknowledgement. And you should know the description or the function of each of these packets. For example, hello packet is used to discover neighbors and build adjacency between them. A database description packet used to check for database synchronization between routers. Link state request is used to request a specific link state record or collect information about specific link or specific records from a router to router. Link state update sends specifically to requested link state packet, or they send link state updates or link state information. And link state acknowledgement to acknowledge the other type the other packet types. To send acknowledgement, once I receive the packet, I will send acknowledgement phases to acknowledgement the receiving of other packet types. These are the main types of open shortest path first packet types. Okay, and this was the last questions in this review. Do you have any question?